So what I want to do is before we get into like installing things and using them, I want to show you how to find them in the first place. And this is something that I think is actually a really important skill. Like I'm in the boat of a good developer is someone that knows how to use their resources. They know where to look, they know when to look, and they know how to try things to determine the value really quickly. Like they can look at something and determine if this thing is valuable or not without wasting a lot of time. And I think that's a very important skill to have that no one really talks about and you don't really train for. And it's something that you develop just along the way. But if you don't have a lot of interaction with this, if you're not responsible for installing things at your company, you don't get this interaction. You don't get to build these reps. So I really pride myself being able to like go on NPM and see what's good and what's not good and try it out and move on with my day and try something else out. So I want to show you how I do that. So NPM registry is, you can think of it as like a database of published NPM packages, and like that's basically it. So we're gonna go look at the NPM registry, npmjs.com. It has a search bar up top, and you can type in pretty much whatever you want. So let's say you're working on an API and you need to get a database. So if I type in database, there's literally something called database. It's an exact match. It's probably not what you were looking for, but there is something called database. And as you can imagine, there are over 500 pages worth of hits that contain the word database. So it would take you a very long time to go through and figure out what's what. So you probably want to come out with a bigger question. So like maybe not that type of database, but maybe you're looking for a specific database. So maybe you'll type in Mongo database and trying to see what plugins they have there. Okay, a little less, not so many pages. We're getting closer. So let's say we check this out. We look at, oh, hey, I'm using Express. Let's check out Mongo. So when you click on the package, you'll notice a couple things. One, you'll see the README here. This is the same README that's probably on the GitHub repository. It's the README.md that's on the root. You can also see how many packages this package has, because packages can have packages, and that's where it gets pretty crazy. You can see what is using this as a package, so what's dependent on this, and how many versions it has, and when they were released, which is also really cool because that tells you how active or inactive this project is. You can also see when it was last published, which is a good sign. So what I like to do is when I come here, I try to find the thing that I like. I try to see that, make sure it was relatively updated. Like if it says 2 years ago, unless there's literally nothing else, I probably won't use it. If it was updated 2 years ago, if there's other things, this is probably the last thing I'll try. I'll go try something a little more recent, the last couple months or something like that, the latest. You can also go check out the GitHub to see the source code, to see the open issues, open pull requests. These are all good signs. If I look at an issue and I see that, okay, this issue was open 15 days ago, this is a pretty active project. So, this is a very good sign that you have some support here if you need it. Because at the end of the day, this is created by some developer just like you, some engineer on their free time who just happened to do this. They probably have a full-time job and a family, and they're not getting paid to do this. So but you also need this to work. So like you can't demand that they fix it. You're not a paying customer, but at the same time, you do want it to work. So you got to work with them. It's open source. You can create issues, you can fix them yourself, you can make pull requests, different things like that. But at the end of the day, you do want a project that's at least maintained and has some type of maintainer behind it that's keeping it up to date and things like that. So that's what I would do once I find the thing that I want, and then I would install it. So one I know that it's really good is Lodash. If you go here, we can see Lodash is pretty good. Updated 4 months ago, which is honestly pretty crazy because I don't know what else they're adding to this, but yeah, Lodash is one. They even have the copy and paste commands that you can use here, which is really cool. And that's what we are going to do. So that's pretty much my process of how I figure out what I want. So if I'm going to use something like Lodash, this is how I would do it. I would go into my terminal. I would type in npm install. Then I would type in the name of the package that I want, which is Lodash. And in fact, actually, before we install it, you can do this. You can say npm info Lodash. And it pretty much gives you the same stuff that we just saw on the website. So that way you can see it here in your terminal. You can see keywords, GitHub URLs, maintainers, when it was published last, all different types of stuff. You can do that. I think there's also like an npm search. You can search through here in your terminal too, but nah, I don't know about that. I don't think I would do that. So yeah, now let's go on to install it. So I'm gonna say npm install. I'm gonna say Lodash. But instead of hitting enter, I'm actually gonna pass a flag. This is a flag, by the way. When you do dash dash like that, that's a flag. And you can think of flags as like options that we pass into a command line tool, which you will be making soon, so you'll know exactly what that means when you make it. But we're gonna pass one that says save, and I'm gonna hit enter. So you can see it went and downloaded it. You get a couple things here. You get some notices, you get some warnings. You can ignore the warnings, you can ignore all of this. This is not for you, it's not to mean anything. Sometimes you'll see errors here and you should maybe look for those. Even sometimes it's not that big of a deal. And then you can see we added one package, Lodash version 4.17.21. So major version 4, minor version 17, patch 21. We added one package from 2 contributors, and that audited one package in half a second. 0 vulnerabilities. So like they're really checking for everything. Now, if we go back to our code, we have 2 new files now. Well, 1 new file in 1 folder. We have a package lock JSON, and we'll talk about that. And then we have node modules. So this is what I want to start with. Node modules. If you open it up, there is a lot of code in here. Well, like, what is all of this? Why is all this code in here? How did it get here? I didn't ask for any of this. I just installed Lodash, but what is all of this? Well, these are probably the dependencies on which Lodash depends on, because packages have packages. And I know Lodash recently kind of like broke everything up to be their own individual packages. And I would imagine if you install Lodash by itself, it just pulls in all the individual packages and like bundles them for you. So these are all the dependencies that Lodash actually needs. So that's what's inside of here. And if you install something else that has a similar dependency and there's a conflict, NPM tries to resolve that conflict by like going to like the most common version, and it keeps everything flat and not nested and different things like that. So there's a lot of work going on behind the scenes of NPM to make sure that your modules are like conflict free, you have the right versions, you don't have duplicates, different things like that. And it's all inside of this node modules folder. So you should never touch this folder. You should never be coming in here and adding files and trying different things and stuff like that, because it's just going to get wiped out every time someone runs npm install. This folder is also not meant to be checked into source control. So what you would do is you would make a git ignore, and you'd add node modules to that, because let's just be honest, you don't want to send up a bunch, let me put that there. You don't want to send up a bunch of third-party code that's not yours into your source control to be processed by whatever CI that you have or code reviewed by someone. Can you imagine a pull request of all of these files when all you did was install Lodash and use it on one line, but now your pull request has all of these in green? That would be crazy, right? So you don't check this into source control. So how does someone, like someone on your team or another machine on the CI somewhere, how do they know what modules that this app needs if you don't check it in? Like, how do they know to get that code? Well, that's where that save flag came in. So when we did the -- save, what we actually did was we told npm to save the name of these dependencies into the dependencies object in the package.json with the current version. So when anyone else pulls this down from GitHub, minus the node modules folder, all they would have to do is just run npm install with no arguments, and that's going to look at the package.json to determine what packages need to be installed, and then they will be installed there. Now, to make sure that they install the exact same versions as that you have, or what's supposed to be there, the package.lock JSON was introduced. This does exactly what it sounds like. It locks the packages into the exact resolved the exact resolved version that npm decided was correct. So if there's any like conflicts between versions, if there's any duplicates that were resolved, whatever they resolve to will be saved in this package lock JSON, so that everyone on your team guaranteed to have the exact same dependencies with the exact same versions, and there should be no discrepancies between that. So that's where that comes in. So all of these work together to do that. That was a lot. Any questions on packages and npm before we move on? So yeah, the question was, how do we know if the code is malicious? Well, I'm gonna say this: you don't. You literally don't know. There is no way of knowing. So I'll tell you how we've gotten to this point where like that's been, even though you don't know, how that's been almost entirely avoided. It's because of the community. So typically, one, just because you make a package, that doesn't mean a lot of people are going to install it. So that's why you should probably only install packages that, like I said, are being used by a bunch of people that kind of vets the fact that, hey, it's not malicious, it's on GitHub, you can see the code, people are making issues, there's multiple contributors, it's being sponsored by big names, so that's a good sign. So don't just install something that no one else, didn't install. And if you have to, go on GitHub and look at the source code. If you cannot find the source code, you can install it, just don't run it, and then go look at the code in the node modules folder, don't run it, and just see what it's doing. You can see what it's doing and kind of figure out for yourself. But at that point, it's probably not worth it. You should just go find a better alternative, or just whatever you're trying to install, just make it yourself. Because if you got to go dig in the node modules folder to see why this thing or how this thing is safe or not, it's probably not worth it, in my opinion. But yeah, it's mostly the power of the people that prevents that from happening. Whereas like I can't think of like one big event where there was something malicious, but I can think of plenty of events where like someone changed something in the code and it broke everything downstream. Like someone changed this parentheses to this, and now every package that depends on this is broken. That has happened a lot. Yeah, so the question is, what's the difference between NPM and Yarn, and why do people choose one over the other? So Yarn was created by Facebook some time ago, because at the current time when it was created, NPM was in this state of just basically not being updated. It was really slow. It didn't have this feature of like deduping. It didn't have a package lock JSON at the time. So there was just so many issues around NPM, and it was the only thing around, so people just dealt with it. I guess the folks at Facebook got tired of it, so they made Yarn, which was exactly like NPM, but it like did caching, and it like resolved versions, it deduped things, it stored them flat. And so people started using Yarn because of that, because it was literally the same thing but better. It was exactly what they wanted from NPM. And then soon after, because of just how competition works, NPM was like, well, we're gonna do that too. So now NPM just does the same thing as well, just as good as Yarn, if not better. And so now it's like, well, whatever one you want to use is probably the one that you're gonna use, because they all kind of really do the same thing. And as far as like where they get the packages from, that's a sweet thing about these managers. Either Yarn or NPM allows you to basically point to whatever registry you want. NPM is going to default to the NPM registry, and I want to say Yarn defaults to the Yarn or the NPM registry as well. I would have to check on that depending on what version of Yarn you're using, but you can point to whatever registry you want. Even GitHub, who owns NPM now, well, I guess Microsoft owns them now because Microsoft owns GitHub, they have their own registry as well. So you could point to that and download from a GitHub registry. It really just, as long as the registry follows the way that the package manager is expecting to interact with it, or if someone makes a plugin for it, then the package manager doesn't really know what it's talking to or who it's talking to, and you can pretty much pull from anywhere. Is the package folder name important? No, I just called mine package because I couldn't think of a better name. You can name this whatever you want. It has whatever you name this folder has nothing to do with anything other than, I guess, the name of what's going to be in the import statement if someone were to like drill into it. But the only thing that's really important is the main field. This is so like if I were to import this package from inside of another app, the way it would look is, because the name is called app, it would look something like this. It would be like, I would be importing, something from app. It will look like that. That's exactly what it will look like. And you can see I'm only using the name of the package, not the name of the folder that the package is in. It's just that name field. And if it's like scoped, it might be something like, my GitHub name or my NPM name / my thing. That way it's scoped. You'll see stuff like that. Companies use that a lot. Companies will have something like, some company here / app or something like that, or / lib, utils, whatever. You will see that. So yeah, it's a little different when it's a little different than like what you would normally think, but yeah, it's just the name field that determines how you import it and not the name of the folder that the package is in.